Alright, so it's a new method called the shell method. And some important things to know. The radius, when you're doing the shell method, is parallel to the rotation line. So when we've been looking at the radius on disc and washer, I don't know if you've noticed, but like if we were going around the x-axis, our radius was always perpendicular to what we were rotating around. But this time, our radius is going to be parallel to what we're rotating around. And that sounds odd, but that's what's going to happen. We're going to take it, and our radius is going to be parallel. And that's important. The formula here for the shell method is going to be 2 pi a to b of the shell radius times the shell height. This is coming from, what's happening is that we're going to take like a cylinder, whichever way. Let's do the up and down cylinder first. The formula for finding the volume of a cylinder is 2 pi r(h). 2 pi r(h). So we're finding the volume of one cylinder, and then we're adding up lots and lots of cylinders to make a certain figure. So instead of like finding the area of a disc or washer and adding it up, we're finding the volume of a cylinder and adding it up. It's just another process that will give us the same volume a different way. Okay, so this formula comes from doing 2 pi r(h). Alright, it's opposite of disc and washer in that when you rotate around the x-axis, you're going to have y's in the equation. When you rotate around the y-axis, you're going to have x's in the equation. So again, that's opposite of what we've been thinking. Okay. The shell radius is based on whatever line that you're rotating around. If you're rotating around the x-axis or the y-axis, then your shell radius is going to be x or y. If you're rotating around another line, your shell radius is going to be whatever you're rotating around minus x or y, whichever way we look at it. And I'll show you that when we look at these examples. And then the shell height is based on whatever the equations are in the problem. So shell radius is based on what you're rotating around. Shell height is based on whatever the equation is in the problem. Okay? So here's an example. The first ones that we're going to look at are all, it says the axis of revolution is vertical. That means on all of these, we're going around something that looks like the y-axis. The first ones are the y-axis, and the last ones are something other than the y-axis. Okay? So, we're going to do 2 pi, and then integral, shell radius times the shell height. So it's something times something every time. There's no squares. There's no trying to figure out if there's a hole or not, anything like that. We just actually figure it out. So, here's what we do. We're going around the y, and what that means is you're going to be in x's because it's opposite. So this is going to be a to b. But because we're going around y, our radius is just from the y-axis, and it's represented by x. If you're just going around the y-axis or the x-axis, your shell radius is either x or y. Alright, your shell height is represented by the function. And if you think about the height, here's the height, and the height is just the function. It's going to 0. There's no other function, so this is just f of x. Alright, so we're still going around the y-axis, which means it's still a to b. It means that our radius is still x, because we're going around the y-axis. Alright, our cylinder height, so here's an example of a cylinder here. It's f minus g. And they went ahead and wrote that the height was f minus g. I just want you to see where it's coming from, because it's just f minus g. All right, the next one is going around some other line, but it looks like the y-axis. Because it looks like the y-axis, we still do everything in terms of x. So our radius, whenever you think about the radius, we know that from here to the function would be x, but we have to add on the part that you're rotating around that's below the y-axis. So it's kind of saying x minus c, because that's, or x plus c, because we want to add in this part right here. And so we can't subtract that because that's being added to it. So our radius is x plus c. And then our height doesn't change. It's still just the value of the function minus 0, so it's just the function. Okay, let's look at some more. All of these are going around something that looks like the x-axis. And so all of them are going to be from A to B because that's the x's. Again, this is going around something that's below the x-axis, so their x plus c is still there for the radius. And then for the height, it's just function minus function. So that's why it's f of x minus g of x. 2 pi integral, still x's. Still two things to multiply. Alright, this time where we're rotating is up here. And because I'm coming from where I'm rotating, we're going to do c minus x. Okay. Now when we did disk and washer, it didn't matter whether you did c minus x or x minus c because you were going to square it. And squaring a negative makes it positive, so it was no big deal. But here we're not squaring it, so it does matter. X is something in the shaded part, and so c is bigger, so c has to come first, so c minus x. The height, again, is just the value of the function, so that's just f of x. Okay, one more on this type. So we'll have 2 pi from A to B. It's still c minus x. And this time, the shell height, it's got two functions here, f minus g. And we just subtract. Alright, so same kind of process, but this time we're going around the x-axis, or something that looks like the x-axis. So let's talk about how that changes. So, excuse me. When you're going around the x-axis, you have to use y values. So this would be A to B. And what we put in here has to also be y values. This, again, is our radius. And our radius is just coming from where we're rotating. And we're rotating around x. So our radius is going to be y. And then our shell height is going to be sideways because it's coming this way. That's why it's parallel to the axis. And it's just one function because you're going to subtract 0. And that one function is f of y. On the next one, oh, I forgot the 2 pi there. The 2 pi always goes in front, like the pi goes with the disk and radius, disk and washer. So we would have 2 pi again here, going from A to B. We're still going around the x-axis, so our radius is y. And then we're going to subtract the two functions, left to right, or right to left, and that would be f of y minus g of y. The next one, we're still going around something that looks like the x-axis. So this is still y's. Because our rotation line is a negative, we're going to add it to the radius. And then our height is still the same as it was on all the others. Alright, on this one, we'll have 2 pi. Again, a to b. Alright, we're still rotating around something that's negative, so that's still a y plus c. And then our radius height is coming from right to left, and still the f of y minus g of y. Alright, the next one, still a to b. Our radius height here is above where we are, so this is why we have to subtract instead of add. And then our height is from side to side. It's just going to 0, so that's still f of y. And then our last one, still a to b, because we're going around something that looks like the y-axis. Our radius is c minus y. And our height we do need to subtract. So g of y minus f of y. Yeah, I don't know why this is what it really shouldn't be. This should be f of y minus g of y. And it would depend on the graph, but I don't know why I wrote it backwards. It should be f of y minus g of y. That's the way they wrote it in the problem. Okay, so here's a problem where we want to use the shell method to find the volume of the figure when we rotate it around the y-axis. So, according to Desmos, our picture is just this little small little piece right here. And we're going around the y-axis. When you're going around the y-axis with the shell method, you have to be in terms of x. So that means whatever integral we have, we're going to have x is here. Okay? As far as my radius is concerned, my radius is just from, the axis to wherever in the function. And because I'm going around y, that means that my radius is going to be x. My height, it's kind of like I'm just taking a cylinder right in here. You can sort of think of it like that if you want. So the height of my cylinder is just the value of the function. It's going to the x-axis, so that's just 0. So my height is negative x squared plus x. I can use Desmos to find out where it touches the x-axis because we're in x's. So it looks like we're going from 0 to 1. Alright, let's do the same figure. But this time, let's rotate it around a different line. So here's the figure again. But this time, I want to go around x equals negative 3. Okay? So I'm still going to have 2 pi. Still going to be 0 to 1, and then something times something. Radius times height. Okay, I'm going around negative 3. So my radius has to do with the x and the negative 3. So it's kind of like I'm saying x minus negative 3 or x plus 3. My height does not change because if you think about the little cylinder part, the height of that cylinder is still the same. It doesn't change from 1 to 2. So my height is still negative x squared plus x. The only thing that changes when you're rotating around a different line is the radius, not the height. Okay, let's look at another figure. Sine of x squared. And I'm going to make sure that I am in radians. And now it looks really weird. And I think that it should tell you some more information, like the first intersection after 0, something like that. But from here to here is the part that it's interested in. So probably I should give you more information except for just sine of x squared. But that's the part we're looking at. So our figure is something like this. And we're wanting to, again, go around the y-axis. So it's going to be 2 pi. And then our radius, because we're going around the y-axis, is just x. Our height, again, is very similar. It's not really changing. So our height is just sine of x squared. And then our values here should be x values. So according to Desmos, we're going to go from 0 to 1.772. I will tell you that comes out to be square root of pi, although you don't have to find it that way. Okay, a few more, and we'll practice some. Alright, so what if you have two different figures? Instead of just one figure, let's say you have two different figures. So we have the square root of x and x. So we have this figure that you've been seeing a lot probably. And we want to go around x equals negative 4. Alright, with the shell method, I know there's a 2 pi. X equals negative 4 looks like the y-axis, so I know my radius and my height are both going to have x's in it. So it's going to be x for the radius, and then I need to add the 4 to it because it's below. So that would be x plus 4. And then the height is the height of this part of the function. And basically you're just subtracting top minus bottom when you're trying to figure out that radius to get the height. And again, we're still in x's. So the curvy one, which is square root of x, will come first. So square root of x minus x. And then this will be 0 to 1. It's 0 to 1 because on the x-axis it's 0 to 1. It is on the y as well, but there's the reason for that problem. Same picture, and this time let's go around x equals 10. And so I just want you to see how that changes everything, or if anything. So it would be 2 pi, and then still from 0 to 1. Our height is still going to be the same. That never changes. It's the radius that changes, and the radius is based on what you're rotating around. We're not going to add the 10 to it because x is just from here to here. So actually 10's bigger, so we want to do 10 minus x. So that's where that's different. If it's a negative that you're rotating around, you add it. If it's a positive, you subtract it. Last question. And this one is one where we're going around something that looks like x. So same figure, but this time I want to go around 3. We're still going to go 0 to 1 because on the y it's still 0 to 1. Y equals 3 looks like x, so that means everything needs to be in terms of y. So our radius is going to have a y with it, but because 3 is bigger, then it's going to be 3 minus y. And I still want to subtract my two functions together. I'm going to think about drawing that little cylinder thing, or the height. And when I do that, you have to do it from this side because this side is bigger. And the x would come first, which is not x because we need to be in terms of y. And so it's going to be the y that comes first. And then the curve, which when we solve that for x would give you y squared.